Okay, so when I get done with this thing, I like coloring everything up and making it look pretty, and maybe throwing some more detail in here. And we're going to be setting up relations for this thing to create our new clamp. So to get started, let's just color this up. That's the first tweak I'll do. So to do that, what I'm going to do is need simplified reps, but I'm going to color everything. I'm going to go to View and then Appearance Gallery, pull down on that, and select the color for this thing. And I think a nice bright color. Blue ice has always worked. I'm going to paint the model that. Just select the part itself and say OK. And that looks like a nice bright color, shiny. That's going to be our band color. I want to color these independent, these two pieces, the screw and the housing. I'll color those independent. To do that, I'm going to need a simplified rep. So I'll go and create a new simplified rep. I'm just going to call this one housing. And I'm going to select features, and I'm going to exclude everything that is not the housing, any geometry that's not the housing. So let me pull this open. So this, all of those are slots. The spinal bend, these extrudes. And there's the housing. We want to keep that, but we don't want to see the screws, so let's exclude that. And we're ready to go, I think. So select OK. Oops. Say select done. And now we just have a housing there. So let's close this up. So that's all that's being shown now is the housing. So let's change its color. To do that, pick the feature, pick a surface on the feature, and then right click and select I believe this one. Select solid surfaces, pick that one, and it's selected every surface of the entire model that's appearing in this rep, and that happens just to be the housing. So let's paint that a different color. Let's make that a nice orange, and we're done with that one. So let's go back to our simplified reps again, and let's go to master rep and create a new one. Let's create a screw. So we got to get rid of everything, features once again, and let's go pick up everything again. Including the housing. Okay, so the only thing left is the screw. Select done, and now we just have the screw, and close this. So I'm going to select the feature, select the surface on the feature, zoom in if you can't. There's a surface, right click, and this is solid surfaces. So pick that. So I have all the surfaces selected. I'll make this a different color. Let's make this a nice, how about a red? And let's tweak it a little bit. Go to Edit Model Appearances, and let's bring this up to a shinier. Let's change the color a little bit too. Let's go to a color wheel, and let's pick where it's at. Let's make it a little bit dark, too dark, too dark. Well, right there, right here is where it's at. Let's see if we can move that around to a better color. That's good. Whatever color you like. And now we have that painted. Now let's go back to our simplified rep. Oops, simplified rep. And go back to the master rep. Regenerate, save what we got. And now we have a colored part there. Okay, now we're going to set up some relations so that we can create clamps from here. This particular clamp family has a big range of clamps it can be made from. When I say clamp family, I'm saying that the same clamp that uses this screw and this housing, there's many different ranges that's available. And the smallest goes down to 1 inch. Ours is in the middle somewhere at 2 5/8 to 1.75, but there are clamps that go, say, from 1.5 to 1. So we got to make sure that when we save this clamp, in other words, we're going to change our max and min diameters. If we change those, we're going to make sure that we create a new clamp that is it's not going to fail. We don't want any failures occurring when we're trying to make a new clamp. So we're going to set up to relations to set that up. So I'm going to go to relations. Let me delete those. So I'm in relation. I'm going to put it right here, and I'm going to create a couple parameters. Actually, just create one. I just need to know when the maximum diameter changes. I don't care if the maximum diameter doesn't change. I will check for minimum diameter also. If the minimum, like somebody changes the minimum and tries to make it bigger than maximum, I'll fix that. I'll sense that. So we need a couple parameters, or just a single parameter to remember what this was, what the max diameter was, and I'm going to call it old OLD underscore max, and I'm going to set that equal to max. And notice that I don't have any parameters here. If I hit the check mark, it'll create this parameter, old max, and it's set it to the max, so I don't need this anymore. So now I'm going to set up a relation if max, in other words, somebody changes this. So if max does not equal old max, I sense that I'm going to have to create a new clamp. Resize everything, change the perimeter, change a few other dimensions, initialize, basically initialize something. So let's do that. If the max diameter changes, what I want to do is set the perimeter and set how much of the tongue sticks out, how much that sticks out, how much do I need. So I'm going to say if old max, so if they're not the same, I'm going to make them the same. I'm going to now set old max to be equal to max. So it's going to get the new max number. First thing I'm going to do. Next thing I'm going to set the perimeter. And what I'm going to do on that perimeter is set it just a little bit bigger than the max diameter. So let's go get that perimeter dimension. I'm going to highlight this. Find the perimeter dimension. I'm going to set that equal to pi, which is just pi, times max, plus, let's try 32, because I've already tried it and it works out pretty good, plus 32 more millimeters. 32 more millimeters. No, let's go with, not 32 millimeters. I'm working with an inch clamp. So I'm going to set the parameter to be equal to, let me get a space in here. Let's set that equal to 1.2. So 1.2 inch more than the perimeter of the max. So the perimeter is that's set. And I'm also going to set this radius here. This radius right here. I need that to be a little bit, maybe 0.6 times the max diameter. So equals max times 0.6. And let's see if this works. And then end if. And now I'm going to check if the min is bigger than the max. So I'm going to say if the min is greater than or equal to, max. I'm going to check those two dimensions. I am going to set, let me get rid of that space there, put a little space there. If it's greater than the max, the min can't be greater than max. So I'm going to just set it, the min must equal the max minus, say 0.25, something like that. A little bit smaller. And if. Okay, now let's see if we can create a new clamp. I think that's enough to create a new clamp. Select OK. Regenerate. Nothing happens. Okay, now let's try to change that min. So max min, I'm going to try to change the max and see if the calculations come out right. If not, we'll have to tweak them. Let's say our max is now going to be maybe 3 inches. And it failed. So let's go take a look, see why. Let's add a definition here. See if we could see what's going on. And this actually looks okay. Looks okay. So that worked. That's odd. I regenerated it twice, and it didn't go back to max. It didn't go to max though. Look at this. Oh, I think I know what I forgot to do. I forgot to reset this thing. Let's try that. Let's go to relations again. And let's make this dimension, that's why it failed. Okay, so let's make the hose diameter equal to max also. So let's do that. So I'll put it here. This is our flexible hose diameter. This is flexible. And let's set that to max initially. And try that. So let's reset this again. Let's try it. Didn't accept it. So let's do max min again. Let's do that at 3.25. And regenerate. It looks like the tongue is not quite enough tongue there. I need a little bit more sticking out. So let's go ahead and add some more, maybe 1.5 inches. Let's try that out. Just to initialize that. And let's go to this. And oops, that's the flexible one. I don't want that. So let's make the max min, let's make this 4. That looks better. There we go. Now there are limits on how small this can go. I don't know if a clamp this big can go down to whatever that is, 1.75. Let's try it, just see what happens. Let's see if we can take this down to 1.75 and what happens. Let's bring it down to 2 and see what happens. And I guess it does. Let's bring it to 1.75. So it doesn't fail. That's pretty good. But look all the slots you got to put in a clamp going that range. So your number of slots is going to depend on your range. So I got to add a bunch of slots here. But I don't think you're going to find a clamp that'll go from 4 down to 1.75. I don't think that's a reasonable thing. Now let's go change our max min again. Or let's say if we have it in this situation, can we change our max min and get it fixed? Let's bring this to 5 inches. Okay, and regenerate. So this thing is recreating itself. You just got to set the min. I'm going to try to set the min bigger than 5. So if I try to set it bigger than 5 at let's say 6, making it bigger than the min, it pops it back down, which is great. So that just prevents bad things from happening. Okay, so let's say our minimum is say 4. So now we have a new min. So if I try to get my flex dimension down less than 4, say 3, it'll just snap it to 4. And that's what it did. It snapped it to 4 because that's the minimum it could go. And then we got to add probably some slots for that range. And to see your slots, you can do the turn on your cross section. I'm in the middle of something here. Let me regenerate and activate this. And you can see that you need a few more slots. Maybe 1, 2, 3, 4, 5, 6. 6 more slots would look. You don't really have to put the slots in if you don't really want to give that kind of detail. But I'm going to go ahead and put 6 slots. So I'll edit this and say 6 more, which is 42 slots. And just remember that when you're creating a smaller clamp, to subtract these slots before you do it. I could do some basic calculations to get the number of slots based on the range, but I think it's easier just if you're going to make a small clamp, set the slots for small first. And so now we have the relations set up so we can make any size clamp we want. I believe we could really anything. Now let's try to make a real small clamp. Let's go back down to like say a 2. Okay, made the calculations. And things start to get weird when you get down to smaller sizes. There's a gap here. That tends to get too big. So what we're going to do to tweak that is if it gets down too small, we're going to just start getting this smaller too. This number right here, this 50. like say the smaller that number, the closer we bring it here, but the less gap it's going to have. For instance, if I change that 50 down to 0.25, it didn't like that. That's too small. Let's bring it to 0.3. 0.3 seems to work. I wonder why 2.5 failed. Gotta look into that. And regenerate that. So when you get down to the smaller clamp sizes, you'll have to tweak that a little bit. Okay, so there we have our small clamp being sized, and the length of this is constant. I would think that we got our relation set up. That looks like a clamp you buy in the store, the auto parts store or something. So now we're complete. I believe we got this clamp flexing down. We could probably bring it down even more. Let's bring our, notice that my min geometry automatically changed because I didn't change it. Let's bring it down, see if we can get it down to a 1 point, maybe 1.5. Let's see if that'll fail. So 1.5 didn't fail, but it actually works still. And this clamp could go down to 1 inch, so I'm going to make this 1.25. See if I can get that to work. So I got it down to 1.25. So far so good. Let me regenerate. You might want to tweak it when you get down to these smaller clamp sizes. You could see that this S bend really needs to get adjusted. So we're going to set up some relations for that when it gets down to certain sizes. So we'll check to see how small that diameter is before we start messing with these numbers. So let me go to the geometry driver just to see how big this should be. So maybe 30 also, 0.3. How about 0.4? Regenerate. Not sure why it failed at 0.3. Let's try to find that out. Why do you think it failed at 0.3? Let's try. Let's bring it down some more. 0.4, 0.35. Maybe we could see something. So it doesn't fail at 0.35. So why is it failing at 0.3? Let's look into that. Now let's see if it's the geometry. It's the spinal bend that's failing, not anything else. And it might be something to do with maybe creating small edges or something. Because this geometry doesn't look bad. This geometry driver, if I regenerate and go to this edit definition on this, let's see what this looks like. It looks like too much of a tongue sticking out, but we could tweak that. But it shouldn't be failing. Why is this failing? So I don't know why this is failing, but I got a feeling it has something to do with these slots. I bet you if we delete those slots, we could find out what it is. We could probably get it to work. One way to test for it, one way to test it would be to go to your accuracy setting, and let's see if we can bump that. Make it 0.05. See if we can get this thing to work. Regenerate that. Didn't work there, so let's go some smaller. About 0.01. Seems like an awful small piece. And as you can see, it is something to do with those 0.01. Got it. Changing that, but I don't want to part with that kind of accuracy. So what I'm going to do is I'm going to go switch it back. So now that just proves that I'm creating small edges. So I'm going to make these slots a little bit bigger. Maybe I can get that to work. So let's do that again. Let's go to our accuracy and change it back to 1,000 instead of 10,000. So 10,000. So it fails there, and I got a feeling if you're doing that, the only thing that creates small edges are these slots. So if I go in there and I edit those slots, where's the pattern at? Right here. If I edit this, and let's make it wider, maybe 0.6. It's 0.046, so 0.05. Does that make it work? Bingo. So just by tweaking that number to a point, we're going to leave it there. We're going to leave it 0.5, but just by tweaking that number, we're letting this work for a real small clamp. And because that looks like too much tongue sticking out, now I've got these things. Let me regenerate. I've got these things being driven by this initial amount coming out. It's one shot. It only changes it if you change the maximum diameter. So we can tweak it after we change, after it creates it'll create this part, but we could change it. I mean, we could go in there and now we could flex. And by the way, that's probably why it was failing, that accuracy thing. It somehow created a small feature. It failed earlier on my first attempt. But on this one, we got too much tongue sticking out. You can adjust that after the fact. So this is adjustable after the fact, like the perimeter. Let's go back. It's got to go down to 1 inch. So let's make this 1.5. And let's go ahead to 1.25. Just to make sure it regenerates this small. Probably have to do some tweaking here. That gap got a little big. Maybe this number needs to be tweaked. So let's just make this maybe 0.28. Still too big. 0.25. 0.25 seems to work. Let's regenerate. So it will go down that small. Let's go get our flex diameter and get that down to minimum. Let's set our minimum first. We didn't set it. So it's automatically set to 1. Okay. It's minus 5.5, so, or 0.25, so it automatically set the minimum. So that's the smallest the clamp can get. So let's go ahead and change this down to, we get 0.5, 0.3. Should snap it to 0.5. Yeah, there it goes. Regenerate. So that's as small as that clamp can get, and we could probably tweak it a little bit by moving this over, maybe cheating a little bit and making this a little bit smaller. There's a few things we can do to get it to look a little bit better, but as you can see, the clamp works fine at these small diameters. Let's check tools, no geometry checks, so we're pretty good. So that's what our clamp is looking like, and we could try it out in an assembly, and I'll show you how it works. So let's go ahead and go back to our original clamp, which was 2.625, and the minimum was 1.75, and let's regenerate. So that's our original clamp, and that looks about right. We need to tweak that. We need to bring that back out again. Maybe we should set a relation. I might create a relation, or I'll let you create 1.3 out there. 4, I forgot what it was. I think maybe it was 0.4 on these bigger clamps. So that's going to be, maybe that should be adjusted until it reached a max. So maybe we could do a relation for that to set those up. Let's go try it out in a hose, on a hose. Let's save what we got, and let's open an assembly. So here's a hose assembly that I'm going to be trying this clamp out on. Got two hoses, this orange hose and a black hose here. And we're gonna, this is within its range. This is under 2 5/8, and this is above 1.75. So let's try our clamp out here. So I'm going to assemble it, and I'm going to use the predefined flexibility. And by value, I'm going to select diameter. And I'm going to pick on this tube here and use that diameter. So it's 1.98, so it's smaller than the bigger than the minimum, smaller than the maximum, so it's going to work fine. So select OK. And it placed it over here somewhere. Let's just drag it to where we need it. So we're going to use this inside diameter here. You want to be using this or an axis. Maybe we should throw an axis in our clamp for people to use. If you have other users that like using an axis, maybe we should throw that one, an axis in there. But for now, I know I'm going to use this. This is the one that's exactly the tube size. This one right here. And remember, this changes and gets a little bit bigger to accommodate overlap. So I'm going to select this diameter here and this diameter here. And then let's drag it into position a little bit. And let's just do an offset from there. And that's our first clamp. And that looks about right. Let's see what the clamps look like when you put them on. So let's put another clamp on. Let's clamp this hose on. So assemble, clamp, yes. By value, I'm going to go by diameter and select this diameter. Select OK, OK. And let's put this one on. Use this diameter and this diameter. And let's flip this around a little bit. Let's use this surface here and this surface here. Check mark. And everything's green, everything looks good. So there's the clamp, the same clamp, using flexibility. Okay, so our clamp looks complete. Looks like we've done everything, and now we're ready to really tweak it. So now what we're going to do is tweak it a little bit. What we're going to do is get these threads on this screw to line up with these slots. To show you what I mean, let me get a cross section going here. Activate that. And what we're going to do is we're going to get these slots to line up with these threads. So how we're going to do that is, and we're going to keep them lined up. As this clamp gets smaller, we want those threads to keep getting smaller. I mean, staying in line with those slots. That's what we're going to do. And this is more of an exercise in relations, than we probably won't do this for a real model. It wouldn't hurt it. You don't have to do it once, but there is a little overhead involved. So the first thing I'm going to do is set up some relations to find out how much this clamp moves when the band gets smaller. How much material comes out. And I'm going to calculate how much it started with. How much did it start with, and how much is there now? And from that, I can do a delta. How much material came out of there? How many spaces went by? And knowing how many spaces went by, like 6.5 spaces, I'm going to have now 6.5 spaces. If 6.5 spaces go by, I only have to turn the screw a half a turn to keep it lined up. I mean, it's not lined up now. We'll line that up in a minute. But what I'm saying is that at 6.5 spaces, we only need to turn the screw a half 380 degrees, because we don't care about those 6 spaces. We care about the fraction that went by. So whatever that fraction is, that's how we're going to turn our screw, because we don't want to just spin the screw. I mean, who cares if it spins 360 or 720, whatever. We don't need that. We just need the fraction that it turned. We need the fractional turn. So to begin, I'm going to create some information. I'm going to go get some information about this arc that's coming out. Okay, so let's get out of this cross section, because it's kind of hard to work with that cross section going. Edit definition of this. And this is an arc right here. This is the arc we're concerned with. It has a constant radius. This radius does not change as the clamp gets smaller. This is constant. And we initialize it, but it's constant. So what we're going to do is we're going to draw a line from this point straight out, and we're going to make that line equal to this arc length. And here's the equation for arc length. So basically it's 2 pi r times the angle divided by 360 degrees. So that's how we're going to do the calculation. So let's go throw that calculation in there. So I'm going to go to my relations again and add another line. And I'm going to say the length of this, which is sketcher dimension 31 there, must be equal to 2 times pi. Pi in Creo is pi. I like doing it like that, times the angle, the radius, which is right here. This was the radius. So that's the radius. So it's 2 pi r. Then it's by the angle divided by 360. And the angle's down here, so multiply it by the angle times the angle, and then divided by 360. And that should give us a length. This length right now, the 0.94 that you see there, is the same length as that arc. Okay, and let's make this a construction line. It's not part of the geometry. We're just using this for calculations. And what we're going to do is, as this gets bigger, like this is home. As it gets bigger, this is where it starts at. This is where it starts. So as it gets bigger, we're going to find out what the delta is. How much change, how much more came out, because that's going to be calculated here. And we're going to find out how much more comes out, and from that we can tell how many times the screw has to turn. So if it's 6.3 times, then we turn the screw 0.3 times 360. Basically is what we're going to do. So that's set up, and we need to find that home position. So when we set up this clamp, we set up the relations that if we change this max min, we initialize some things, and that's one of the things we're going to initialize for this screw. We're going to call it the home, and that is going to be equal to the length of that dimension we just created. This dimension right here. We just created that one. So that's what it's going to be. I say OK. Now home is not set yet because I haven't changed the clamps. Let's make a small change to max min so I can initialize this thing. And I just have to make a small change, so 2.6, and then regenerate, and let's go take a look and see what that came out to be. So we'll go to relations. So I'm sorry, we should have just went to parameters, but here we go, parameters, and you can see home is now set at 0.94, which is the length of that line. So when we make this clamp smaller, that line is going to be longer, and we're going to find out what the difference is from home to that. And from that distance, from that difference rather, we can calculate how many times we need to turn the screw. Now right now the screw is not lined up to the slots, and that's one of the things, if we want to do this, we're going to have to line that screw up to the slots. Plus, we're going to have to turn the screw from that initial home position to keep lined up with that slot. So what I'm going to do is, before I place the screw, I'm going to create a datum plane to use to line that screw up with those slots. So to do that, I'm going to just do insert here and move it up a little bit above the screw before the screw comes in, and create a plane. I'm just going to select this surface, and let me turn my planes on so I can see things. And then I'm going to select this front plane as a reference, and I want that to be an angle, an offset angle. It starts out at 45 degrees. Let's just leave it at 45. We'll set it back to 0 in a minute. But it's easier to line up when we go to place this component. When we go place the screw, we need to line up with that. And if it's at 45, it's a little bit easier to do. Also, I don't like the plane being this big. I made a very large plane. So I'm just going to go display, adjust on line, and I'll go to a reference and use the same reference I used to create it. So this surface right there for reference, and now I have a nice small plane. It's not this giant plane. So you can see it there. So there's the plane, and now we're going to line that screw up to that plane. So let me exit this insert mode here. And let's regenerate and save. I'm just going to save a lot. Okay, now let's line that plane. Let's edit the definition of the screw and its placement. So here's the plane we want to line up, that one there. So let's add a new constraint. Right now allow assumptions around, so that's why it's not failing. But we're going to pick this plane for a new constraint, and we're going to line it up to this angle plane here that we just created, which was datum 3 here. Line it up to that plane. And we don't want it to be coincident, because we're going to have to, after we line this thing up with those slots, we want to turn the screw after it's been lined up. So what we're going to do is make this another angle offset. And we'll leave it at 0. That we're going to calculate. That has to be calculated as the band gets smaller. So let's give that dimension a name. So I'm going to edit the definition of this. Just edit, not definition, but dimension. This dimension right here, it's the 0 one we just created. 0. Go to properties, and we're going to call this rotate. Rotation. How about rotation? Okay, that's our screw rotation. Gave that a name because we're going to be using that in relation. And now what we need to do is line up that screw. So I'm going to go ahead and use this plane. This plane I'm going to call START. I'll call that plane start. So that's the start plane. Let's set that at 0. Initialize that at 0. Pick that dimension. It was 45. Let's make it 0. So now both of those dimensions are 0. So let's see where we're at. And to do that, I'm going to go to the cross section here and go to the front view and zoom in a little bit so I can explain what we're going to do. We're going to get these threads to line up with these slots. To do that, we're just going to edit this start plane. Here's the dimension right there. Let me get this out of shaded mode, and there's our dimension right there. So let's just move it at 10 degrees at a time, see what happens. As you can see, the screw is turning and the threads are turning in the right direction, so we're good there. If your threads are turning in the wrong direction, you might want to try to flip your direction for that plane, this start plane. I don't think you'll need to if you did it the way I just did it, but if you're going the wrong way, you got to do something else. That plane has to change. I believe all you have to do is change the direction of that plane, like put the yellow side on one, red side on the other, whatever. So I'm changing this a little bit at a time just to show that screw moving, that this thread is moving. So making it 40, and you can see the thread is moving. So it looks like it's going to need to go to about maybe 80. Zoom in. Maybe 85 ought to get it on the money. It doesn't have to be perfect. We just don't want interference to occur. Okay, so there's our slot lined up, and these planes once again are screwing me up. So you can see it slotting. The slot is lined up. So go to shading. There's our screw, and now it's lined up. And of course, we're going to change the screw to extend into that. Why go through all this if we're not going to do that? And like I said, this is just an exercise in relations and how to set them up. So regen, so now we're home, we're good. Now we need to calculate as the clamp gets smaller, how much do we turn the screw? So let's do that. Let's go to driver, edit definition, sketch view, zoom in a little bit so we know what we're talking about. So now we need to calculate the difference as this comes out. We need to know how much this comes out and make some calculations as to how much we need to turn this screw. So to do that, let's go to our relations, go to another line here, and first thing we're going to have to do is calculate the delta. How much came out? Now remember, we initialized how much is there now. This sketcher dimension 31. We did that in part level. We're in section level, but in part level we calculated that. Every time we change max min, that gets reset to the new number. So and we called that home. So what I'm going to do now is calculate delta. How much came out? How much change there was? Capital letters. I'm creating this parameter on the fly. It's going to be this dimension here minus home. Just like that. Whoops, I didn't put a minus. Sorry. Minus home. So it should be 0 now because we haven't changed it. And it's negative something here, right there. That's because of our decimal places. We've only doing 2 decimal places. It did some rounding. So it's given us this negative number. So we got to remember that we could change this. I can go back and do this whole thing over again by changing the accuracy, and this will come out to be 0. But so now we know how much has come out. Now we need to calculate how many spaces is that. Now remember, spaces was 0.1. Let's go take a look at that. You save what I got. And now I'm going to go look at this spacing of this here. If I edit that, this is spacing right here. I'm going to go to properties, and I'm going to call it spacing. Yeah, spacing. I'm going to call it spacing. And now let's go back. That's what we're talking about, how much spacing there. And let's go back to here, and let's regenerate that. Let's go edit definition, sketch view, and you don't really have to go into the sketcher to get to those relations, but I'm doing it just so I could keep these numbers up here while I'm talking. So now we know what the spacing is. So if we take the delta and divide it by spacing, we should know how many times, how many times that screw needs to turn. So let's do that. Let's go ahead and to do that, let's find out first how many full spaces that is. Let's just give another parameter called full spaces. Like that. Now the full spaces is going to be the delta divided by the spacing. That's going to give you how many full spaces. Like this might come out to be 6.9 or whatever it comes out to be. Right now it hasn't moved, so it should be pretty close to 0. But we do have that negative error that out to 4 decimal places, like 2/10,000ths of an inch. But anyway, full space is going to be delta divided by spacing, and if that comes out to be 6.9, well, we can't round that out because 6.9 will round it out to 7. We're interested in the fractional part. So we want to get rid of that integer part, the whole number part. So to do that, we're going to use a function called floor, and put parentheses around our equation there. And now we're saying, give me the floor, and floor is just going to round down. So if this is 6.9, it's going to become 6. And now we're going to do a fraction, and we're going to call that the delta minus full spaces times spacing. And that gives us the fraction. Should be 0 still. Let's hit the check mark. And the fraction is close to 0. Now, like I said, I'm getting these errors, but we don't have to worry about it because our thread doesn't have to be exactly in the middle of the slot. So I'm not going to worry about it. What's happened here is, again, the negative is screwing us up a little bit. It rounded down, so rounding down, when you got a negative number, is going to go to a -1 instead of a 0. If we got a negative number, rounding down goes to -1. That's why we got full spaces at -1. And that, again, comes from that thing with the 2 decimal places on our accuracy, on our decimal places, rather. So the -1 is okay, and that's just because this is negative, that's going to be -1. So now we know what the fraction is. Now we know how much to turn that screw. And that screw, the rotation is going to have to be done here. Now this rotation is that dimension that we turn the screw with. The reason why we're doing it here at this level is if we waited and put this at the part level. Right now we're putting it at the section level of one of the first features here. This will get regenerated first, and you'll get a number for rotation, and then we get past that. Oh, I forgot a T. Forgot a T. Rotation. Okay, and so now if I waited and put this in the part level relations, you'll get a delay, and that would cause a double regeneration. It will still find the spot, but you'll regenerate once, and then it will say you need to regenerate again, and then it would rotate the screw. But if we do it here and pass rotation on early, then we only get one regeneration. That's why I'm doing this here. If I get the fraction divided by the spacing and multiply by 360, that'll give me my rotation. So I'm going to do a 360 times the fraction. The fraction is the fraction amount that came out. If I divide that by a whole amount, which is spacing, divided by spacing, I should get the rotation correct. Hit the check mark. Okay. Okay. I'm going to regenerate just to make sure everything's at 0 and save. Save a lot when you're doing this stuff. So now that I have that set, I'm pretty sure rotation will be pretty close to 0. Yeah, it should be this guy. Edit this. Saying 359. Yeah, that's that -1 that's doing it. But that's not enough to make it unaligned with those slots. So we're not even going to worry about that. So to see if our slots are working, let's go to our cross section. Activate that. Go to sketch view. To front view. Let's take a look at what happens. So right now it's lined up. So if we did our calculations correctly and we change the flex diameter, if we edit that, and we change that, say, 2.5, those slots should still be lined up. As you can see, they are. And they'll stay lined up. Let's make it 2. We'll try it in the full range, make sure everything's running right. As you can see, 2 keeps it right in the middle. And let's go down to our minimum diameter. And to get to minimum diameter, remember, just make this really small. So 5. Oh, I put a big number. 0.2. That'll give us to our minimum. So our minimum is 1.75. Let's regenerate and check our slots. Slots are still lined up. So our math is correct. Okay. Let's bring it back home again. Let's change our max min. I changed it. Let's put it back to where it was. It's 2.625. Now I changed it back to 2.61. Now look at home. Home is not correct because I changed it back to 2.625. So you're going to have to tweak it. Every time you change your max min, you'll have to line this back up. So what you do is just go to your start plane, hit the dimension, and set that to 0 and start from there. 0 and regenerate. And there's also another option. It looks like it's got to go a lot. I can't go backwards. I can only go forwards. It looks like it's got to go a lot. But there's other things you can do. For instance, I could pull this closer, this first one, pull all these slots forward. Probably be easier to do that. So that's an alternate. Or I could go ahead and put that number in. It might go up to maybe 200 degrees. But I could also do this. I could move the location of that first slot. So if I go to that first slot and hit edit dimension, here's how far it is. It's 0.15. If I make that maybe 0.12, just move that forward a little bit. You see that lines the slots up a little bit. That was pulling it too far, actually. So I'll make this 0.13. Maybe that'll get it closer. Okay, so I'm in the ballpark. There we go. So let's regenerate that and go back to a front view. I'll zoom in on that, but just by changing that number, I still need to tweak it a little bit. So needs to go. Well, actually, that needs to go. Still needs to go a little bit more forward. Can't push the thread back. Actually, that's not bad. Actually, tell you what, let's just leave it right there. It looks a little bit too much. I think I will tweak it a little bit. I am going to make it come. Which way do I need to go? Which way do I need to go? I need to come forward. So this has got to get smaller, maybe 0.125. And let's regenerate that. And let's see where we're at. Yeah, it looks about right. Let's go to front view just to be sure. Yeah, it might have been too much. So it looks a little too much. Here's a line. Here's a line that's supposed to be in the middle. So now we might need to go ahead and tweak it. This one is a finer. This one's a finer adjustment than that is. So let's go ahead and use that one. So we'll edit that one, get it off of 0. Let's go maybe to 10 degrees just to tweak it right in place. So as you can see, 10 degrees put it pretty much right on the money. So let's leave it there. And then we'll test our clamp again. Let's save what we got and test our clamp again. So let's flex that dimension. And let's bring it down to 1.75 maybe. And regenerate. And as you can see, the slots are still lined up, which is what we would expect. Now the final thing we're going to do is go ahead and put the thread into the slot, which is the whole idea behind this anyway, so we might as well do it. So let's save what we got and go mess with this screw. And remember that the slots on this band are equal to the pitch of this thread. They got to be equal. So when we set that earlier, so it's set at they're equal right now. I think they're at 0.1. Spacing between the slots is 0.1. It's got to match the pitch of the screw. So let's go open our screw up. Let's open the base model. So here's our screw. And we want to make this a little bit bigger. Our band, it's almost touching the band. So I want to say a 30 thousandths bigger on this diameter, just to see where that puts us. So let me edit this. And let's find that dimension. There it is right there. Let me get out of so you can see it. And there it is right there. It's 30 right now. I'm going to right click, right click, right click. There it is. And that needs to be 33. We're going to add 30 thousandths to this thing. And regenerate. Let's save what we got. And let's go take a look at our model, see if we got it right. So let's go back to our model. I'm going to leave this in so we can go to our clamp here, regenerate. And it goes in there, but maybe not deep enough. Maybe a little bit deeper. We'll play with that. We'll tweak that. But I could tell if the threads are too fat here. We're going to have to modify that. So to do that, we have to make them wider. The cut's got to be wider. So let's go modify that and see how that works out. Let's save what we got. Save frequently, and when you're dealing with this, especially with helical sweeps, Creo has a tendency to get screwy on you. So let's open the base model, especially when you're opening base models. And we'll go ahead and make that just a tad bigger. maybe another 10 bigger. So it was 33. So let's go another, was it 33? Let's go to 34. There. Regenerate. And let's make the slots, let's make it thinner. To make it thinner, and now when you do this, you only show when you actually, I edit that and I double click it, actually that's editing. You only get the pitch and that's it. But if you right click and you go to dimensions right here, show hide sketch dimension, you click on that box, these dimensions will pop up. So let's make this wider, 0.08, see what kind of, still wider, maybe 0.09. And that looks better. I think it needs to go deeper, maybe a 0.05. Something like that. That looks better. It's a visual thing, whatever you like, but that looks good to me. Let's get out of here. Let's take a look at our model. Let's regenerate. And we can see that we kind of moved those threads on us. That's from, so we'll have to reset this thing, but I like how the threads are going down in there. So you got to reset your home again. Let's see what it looks like at max. So we'll go to our flex. To get max, just put big number in here, 5. Snaps it to max. See if our slots are lined up. See, it went out of alignment when we changed that, so we need to line it back up, which means starting over. Okay, let's fix that up. So to get that fixed back up, I'm going to go to start and set this a little bit bigger. This number right here, let's make that 30. Let's see where we're at. Let's regenerate. Oh, let's get in the front view. Be sure you're in the front view. It's a lot easier to look at it. I should just create another view that's already zoomed in. I'm sorry, 30. Let's make that 50. Regenerate. Shaded. Let's go back to the front view and see how we're lined up. Maybe, no, that looks pretty good. So that thread looks like it's lined up there. Okay, so we're done. This is a complete done. The only thing I would do now is just turn all my layers off, hide everything, and save. And now let's open that assembly back up, make sure it's still working. Our example assembly. Looks like it's still working. Okay, so now last part of the video here, I'm going to stop and I'm going to correct all the errors that we stumbled into all along the way. One of them was, the first one I'm going to do is in relations. And this is an error here. This length equals perimeter here. Well, when I initialize a new clamp, the perimeter changes. So this has to come after this changes. So I'm just going to keep these guys together. You don't have to, but I am. Control X that out of there. And I'm going to place it after this statement. So there it is. So that way when I make a new clamp, perimeter gets updated automatically because it's right after it. And save that. Every time I make these changes, I'm going to hit save. And the other one was in this geometry here. We was coming into a negative number, and that was occurring because it was getting rounded off differently from part as opposed to Sketcher. The Sketcher had 2-place accuracy. The part, it was taking it out all the way, whatever it needed to go. But the Sketcher was set up with 2-place accuracy, I think, and we was letting it default that way. Anyway, to get that to work correctly, what we're going to do is we're going to remove the home, the initialization home. And by the way, this D111, I'm going to highlight that and show it. Where's that at? Hit the question mark. Tells me its value. That's that 0.94 dimension. And I'll hit this and find out where it's at. And it's that little piece of segment, that straight line that we drew, a construction line. That's the D111. So I'm just going to delete this from here. D111. So home can't be set here. So what I'm going to do is save that again, and I'm going to go in and redefine this guy. And what I'm going to do is I'm going to set it so that if the flex diameter is equal to the max diameter, Let's see what the flex dimension is called. I'm going to switch symbols here. It's called hose diameter, and then of course this one's called max min, but we're going to say if the flex diameter is equal to the max diameter, that's at maximum, when you first make the clamp, that occurs. So that's how we're going to do it. We're going to just make that check. We're going to say if those two things are equal, then let me regenerate that, and then from that, then we could set our home value. So let's go ahead and go into this because we need to know what the sketcher dimension is. So edit definition of this, and we're talking about this dimension right here, this 94. It's rounded off here, but you can see in the other level, you can see all the decimal places. But anyway, let's set up home here. So what we're going to do is go into relations, and right here, before anything happens, because home is down here, we got to make it before that, we'll set home equal to this number, sketch dimension 31. Okay, and that's set. And let's look at our parameters now. As you can see, I got a negative number in here. I got all kinds of garbage in here. Negative 32 spaces at deltas, -3. I don't know if this didn't get reset or something, but anyway, it has negative numbers down here. And if I hit the check mark, it resets it. Now this is how it should have happened in the first place. I got delta as 0. That's what this should have been. Sketcher dimension 31 minus home, because I just set home equal to that. But this can't stay set. I gotta only have this happen when max diameter is equal to that hose diameter. So let's make a statement like that. If hose diameter is equal to max, not equal to, same as, double equal sign, same as max, then this happens. And if, let's verify that. Let's put a space here and verify that, and that works. So we get rid of our negative number, and we'll check that. Let's check that with a save what I got, and let's make a new clamp, max min, and let's make how about a 4, and regenerate, and let's see what we get. Let's see what we get in our relations. And we're set. You see it stays nice and zeroed out. It's going to zero out. So that looks good. So let's bring it back, max min, to where this clamp is supposed to be. I think it's I'm going to initialize this at 2.625. I think that's what it was. And then we're going to set it just to try and make sure everything's working right. Let's do the flex diameter at minimum. I forgot what minimum was. 1.75. So this needs to go to 1.75. Make sure this is all working. Don't want any problems here. Let's regenerate. So there we have our clamp, and it looks like it's got too many slots actually. We probably should get rid of some of those slots. Let's go clean that up a little bit. Let's see where we're at. Let's get a cross section going. Activate that cross section. And I don't think we need, oh, it didn't line up. I gotta reset this thing. Somehow it's not reset. Let's go ahead and reset this thing so it lines up. So if I remember right, I gotta set this back to 0. So if I edit that and make it 0, regenerate, let's see where we're at. Well, first let's get rid of these extra slots. We got 1, 2, I think this one, we got 4 extra slots. So let's go ahead and fix that. 4 extra slots. So this should be really 38. And let's regenerate that. There we go. Now let's line things up. And 0. Maybe I should push things back a little bit. Let's get this in max. I gotta be doing this at max anyway. So flex diameter, I need to go to 2.625. Let's regenerate that. And let's see where we're at. Same spot. That's a good thing when you see them in the same spot. So a little bit I think I'm not going to mess with this one anymore. Let's just get this one here because it looks like I'm going to have to rotate it no matter what. So let's go to start. I mean, not start. Let's go to that first one again. And I'm going to reset that to, I'm going to reset that back to maybe 0.1, 0.12. That's where it was. Something like that. And we'll start with that setup. So the screw has to go quite a bit, like at least 180. So let's just go ahead and get our start directory, start dimension, and set that for 180 maybe. Regenerate. Oops, regenerate. Gonna have to go more, I knew it. So let's go to a front view, just so we can keep an eye on things here. So edit this. I think it needs to go at least 30 more maybe. Maybe let's try 200. Nope, 220. And it looks pretty close, maybe 230. 235. And then we regenerate. And now let's see if that works by making this flex down to a smaller number, maybe 2. See if our relations are working. And it sure looks like our relations are working. So we're good. Let's go reset this thing back to, back to 2.625. Regenerate. And we're just about done. So it looks good. So let's get out of this section, deactivate that, repaint things, save what we got. So that fixes up some relation errors that we were having trouble with. I got the slots corrected. Everything else looks pretty good. I say everything else looks. I'm going to tweak these slots now. I got a different style I want to put in there, more realistic. Let me refit this. So I'm going to redefine this. The sketch view, I'm going to go to no hidden so I can see what I'm doing here. And what I'm going to do is I'm going to put an arc here. Get rid of this line. Let's delete that one. And let's put an arc in then. An arc with center and ends, but I want the arc to be on a center line that's perpendicular to this construction line. So let's do that first. The construction line through the center and then lock it to perpendicular to that. So that these two are perpendicular. So that's where I want the center line of my arc. So I'm going to do arc, center ends, somewhere down here. Oh, I see something that happened. You might not have caught it, but it put a constraint there I didn't want. So I'm going to get out of there. Try it another place. It was locking. I was moving this somewhere down here. It's popping on and off. So I'm going to get it close like that. And I think I could just corner this out now. Corner this. Wait a minute. What we got going on here? What's this all about? I don't want that one. Make sure that one's off. Let me corner this out now. And let's corner this one out. That looks good. Let's tangent things up. And R1 is going to go away. Equal radii is going to go away. And let's tangent this up. There we go. So we're left with these dimensions, and we're going to put a dimension from this line to this arc, and that'll control our width. I guess 0.05 is probably good. No, it's not. Undo that. Okay, 0.06 is about right then. So let's bring this down. 0.02, something like that. What is this one exactly? 0.06, so what was that one? I forgot what that was. 0.06. So 0.055. That looks pretty good. Let's take a look at that one. See if that doesn't look better. Yeah, that looks like a more realistic slot. That looks like a good slot there. So let's save that. And you can tweak this as much as you want. I'm going to throw one more just for grins. I'm going to go open this base here. And I'm going to put a cut in there because I seen the screw, and it's an extrude, remove material, placement, define. I'm going to place it right on that surface and sketch. And for references, I don't want this one. I want to delete this, and I'm going to use this diameter as my only reference. Sketch view. Let's turn out these guys. And let's go into hidden. No hidden. How about that? And what I'm going to do is make it a percent smaller than the hex. So I'm going to do a circle from here, something like that. And that's good. And let's see, how much am I removing? Let's go 0.05, too deep. It's 0.01. Something like that. It had a little red, yeah, that looks about right. Okay. And let's shade that up. It looks something like that. So I'm going to make this diameter I'm going to set a relation up here. And the angle is going to be equal to the hex, and that diameter is going to be equal to a percentage of the hex. So this diameter right here is going to be a percentage of the hex. In case you change the hex, you want that to grow with it, you know, or if you make it too small, you don't. This keeps things from getting goofy on you. So I want that to be equal to the hex dimension times 0.9, 90% of the hex. See what that gives us. Regenerate. Yeah, that's better. So that looks good. So I'll save this part and close this guy up and regenerate this, and that puts that back in there. It looks like I gotta paint that surface. So let's select that surface. So I selected the feature, now the surface, and we'll go to view, appearances here, and it should be, the color should be right here. Oh, there's another one I missed. I missed one right there. That should also be this color. We'll save that up, and I believe we are done. This is a complete clamp that works correctly. And let's finally save that, and hope you enjoyed the video.